Okay, well, it's looks like it's time to start. Here's some homeworks back. Take two, right? Take two for the camera.
Now I'm going to edit that out.
What do you mean? I think we're fine. We don't need to edit out my humor. Today is the what? 27th? Am I right about that?
It's just easier for me to just have it.
All right. Yeah, we have an exam in this class on Thursday, so we will not obviously be recording we will obviously not be doing a video recording of the exam. Just
So do they have
could pan across all the students with their.
Question, how do you do with the guys that aren't attending, how do you do exams?
The people who can't make this hour, we'll schedule a separate time for them to take an exam. Okay. Now, so here we go. It's a test Thursday. And so let me explain a little bit about what the exam's going to be like. Okay, first of all, it's going to be that the exams always have the same format. Okay, there's always, the first question always has multiple parts to it. Okay, so first question, multiple parts, and these are short answer. Multiple parts. Short answer. So, it's things like definitions, and it'll be like, 4 parts of the, or what's the definition of an expression, or what's the, what are the properties, what are the 4 properties of equality? Remember the 4 properties of equality? Ristal, RSTL, reflexive, symmetric, transitive. Not Leibniz. And Leibniz, yeah, so things like that. What's the, do you remember the interpretation of the Hoare triple? You don't remember this would be an example of what, an example of part of the first question. An example, not necessarily that I'm going to ask that one, but remember, like P. Remember?
P replaced by.
No, P. No. It was the Hoare triple had P.
Oh, it's like P and then like X. X replaced by Q.
P S. It's P S Q like this. This is the precondition. This is the statement. This is the postcondition. Remember? Yeah, that is how you, well, yeah, that is how you do that if this statement is an assignment statement. But what is the interpretation of a Hoare triple in general? Do you remember that?
Yeah.
What does S represent? First of all, what does S represent? A what? A statement, a program statement. That's right. And so this, so what's the interpretation of this Hoare triple? If you do what? If P is true and you execute S, it will do what? It will terminate, and what?
And Q is guaranteed.
And Q is guaranteed to be true. So that's the questions like that, okay, are what's going to be on the first question. Okay. And so it'll be lots of vocab, or maybe a truth table. I might have a truth table. Make sure you know the truth tables. Yeah, okay. And then so that's the first question, and then it'll have many parts. And then there will be several proofs from the homework. Okay, and so if you know, and so here's what I recommend you. Here's how I recommend you study. I recommend that you go back over all the homework exercises that are the proofs, and just with this, try to prove them. Oh, and by the way, I will have available this handout. And so obviously you don't have to memorize all of this stuff. So what's in the handout. So you will have a copy of the handout, but then you must also bring an exam book. Okay? You can get them at the bookstore for, I think, they cost 50 cents. Actually, the cameraman has a little show and tell there. Exam book. So you're responsible for bringing an exam book. Sometimes when students forget, the exam book, well, I make a little profit on the side. I'll have a few little extra exam books, and I'll sell you one for $1. So, but I can buy them at the bookstore for 50 cents. So if you forget, you want to, avail yourself of that service, that's fine with me. But anyway, so several proofs from the homework, and then there will be one or two proofs not from the homework. All right? So that's just to make sure that you can apply what you learned to something that you haven't seen before. Okay? And that's usually those are the ones at the end. Okay, so that's, and then the exam paper is just one sheet of paper. I mean, the exam itself, I'll just hand out one piece of paper that has all these questions on it, and then you will do do each one. So bring exam book, and well, the other thing that I ask you to do is start each question on a new page in the book. Okay. So in fact, I wrote on a couple of your homeworks that I'm giving back now. I prefer that some people are doing, 2 columns of proofs on the same page. I really prefer that you don't do that. By a little extra paper, because it helps me to grade whenever I want to write comments. It helps to have room for me to write comments whenever I grade your papers. So bring an exam book and begin each problem on a new page. Yeah, and bring a pencil and eraser for sure. All right? So that's the format of the exams. That's what. Well, I would like to schedule a review session. I usually like to have you guys over to my place. I live on campus. And unfortunately, we have a couple people missing. So if we schedule a time, could you guys make it, those of you who are here, could you guys make it like on, in fact, we could even do pizza if you want. Could you guys make it like tomorrow, Tuesday night? Say the exam's on Thursday. Could you make it tomorrow night? Is that good? Would that be a good time?
UM's at 8, so.
What's it? You have something at 8?
Yeah.
What is at 8?
It's church.
Yeah, church.
Oh, on Tuesday?
It's repository, yeah.
Oh. Well, would Wednesday be better?
Probably. Yeah.
For you guys, Wednesday would be, that's the night before, it's a little bit more of cramming, a little bit more, if we do it on Wednesday. But
it's fresher.
We could do earlier on Tuesday.
say at when? 6? That only gives us a couple hours.
Well, you can have one with them and we can always catch up too.
Okay. So how about Tuesday at 6? Does that sound good? Okay. So.
Talk again tomorrow.
And yeah, right. We can't talk again tomorrow if more people are here then. Okay. So tentative. Tentative review session. 6 o'clock Tuesday. And we'll talk some more about it when we get more people. Okay, well, now I would like to go over some of the homework, a couple of the problems.
The homework you passed back or the one?
First, the ones that we passed back. And then I think we'll spend most of our time talking about the homework that was due today. I think there might be some questions about those. And I wanted, let me see, I wanted to make one comment about a proof. Let me show you, let me see if you can identify what went wrong with this attempt. Suppose we want to prove .330, which is P or false equivalence P. Now, here's what one person did for this proof. He did this: P or false equivalence P, and he put equals. Now, what's the one where false equivalence P is P equivalence false? I mean, P equivalence Q. 3.2, he did 3.2 symmetry, and he made it like this: P or P equivalence false.
It's like as if it would be equal.
Well, yeah. This is incorrect. Yeah, don't write this down as if this is correct, a correct proof, because this is incorrect. But the question is, why is this in? Yeah, so this is. This is incorrect, but why is it incorrect? Can you point out where the error, what? Yes, the problem is precedence, because what this person assumed is that P or false equivalence P. He assumed that the parentheses was like this, but it's not. Do you see what I mean? And so he said, oh, well, false equivalence P is the same thing as P equivalence false by 3.2 by symmetry. But the problem is the problem is that by precedence, the parentheses are not there. This means this. Yeah. So anyway, I thought I would just point that one out. Now, what about the homeworks that I just gave back? Are there any questions about the ones that I just gave back to you guys? Anything that we should go over?
No, I think I'm all right.
Does everybody see where?
Oh, we messed up.
You want to do that one correctly?
Yeah, let's go ahead and prove this. That's a good idea. Let's see, how would we prove this? P or false equivalence P. This is 330. Identity of or, P or false equivalence P. Somebody have an idea about where to start here? P or false? What can we use? We can use maybe false. I tell you what, let's do. I think the way I would do it would be like this. P or false equivals P. Guess what I would do would be to start with the left-hand side and get it to the right-hand side. Okay? So how about this? P or false. Well, what's another way to write false?
Not sure.
Well, yeah.
Or
But then we would just have P or not true, or
P or not P equals
P
P.
or not.
Or sorry.
Oh, yeah. Say it again.
It'd be
Fa-
3.15.
Yeah, I think that's a good idea. 3.15. 3.15 is, let's just write it out here in the hint. 3.15 is not P equals false. Not P equals false. And the nice thing about doing it this way is that we have P or not P equals P. Right? So false, replace false with not P equals P. But the nice thing about this is what do we know about or with equivals? It distributes, yeah. Okay, so so what's the distributive one?
It'd be P or 3.27.
27?
27.
3.27, so it would distribute. So what would we have?
P or not P equals P or P.
And now I think we're trying to get this to P, right?
Right.
So what do we know about P or not P? Excluded middle. Yeah, good. Excluded middle is
28.
28. So that P or not P is true, right?
Right.
Oh, but what about this P or P?
We could either do idempotency.
Yeah, idempotent. Good. So idempotent is what? 3.26. And so that would be true equivals P. And what are we trying to get this to? P. Ah, we're very close. Say it again. Yes, 3.2. Oh, 3.3. Yeah. So equals by 3.3 P, and boom, we're done. All right? Good deal. Okay, so what about your homework assignment for today? Today was all those implications. Yes, he says. All right. What do you, let me get this. Okay, did you have questions on the homework that's due today? There's always questions. All right, good. Well, let's work our way through. Let's work through them then, because I mean, basically there's no new material for me to go over. We can spend the entire time coaching you through the homeworks if you'd like. Just start at the beginning. Okay. Which was the first one? Like 3.61?
Yeah, it's
contrapositive.
Yeah.
Okay, let's take a look.
P implies Q equals not Q implies not P.
Whoops.
Right, that's the way to turn it.
Okay, 3.61 contrapositive. P implies Q equivals not Q implies not P. All right. Now what I would do, let me see, you have an equivals. So let me give you just a general hint here. When you're proving these things with these implies, Your friend is 3.59. That's numero uno.
Oh, see, I tried to do it with 360.
Yeah, if you do it, yeah, you tried to do it with 3.60. Yeah, if you try to do it with 3.60 or 3.57, those usually, here's kind of a heuristic. Whenever you're trying to prove one of these ones with implies, first try 3.59 because 9 times out of 10, that's the one that will help you the most. Okay, so so try this. Try. Now let me see. We have something equivalent something. Now, do you think you? So what I would suggest is start with one side and get it to the other side.
Right.
Now, which is the most complicated? What's our heuristic? Which side should we start with? Start with the most complicated side. Okay, so I would start with not Q implies not P. Now, you've got this style down now, right? Where you don't write the whole thing and then proceed as if you're doing the left side.
Right.
Okay.
Separately now.
Okay.
And now I have the 3.61 and then I do space, I wrote proof.
Proof, and then you start with a good. Okay, I'm glad we've cured you of that habit, bad habit. Okay, so start with the right hand side, and you've got not Q implies not P, right? Okay, so go ahead and do. I'm not going to do a whole lot of writing now, so go ahead and do 3.59, and see what happens
PQ gets replaced by
with
not Q.
not P, right?
Can we skip not Q?
Yes, and then right. Right, and now you're going to use double negation, right? Okay, so not a whole lot for me to write because you're doing this all on your paper. Yeah, twice, I think, right?
What about
You use double negation twice, right? Or no, maybe not.
Just once, as far as I know.
Yeah. No, maybe it is just once.
312 with P is
And then can you use 3.59 again?
and go back to
And then it should fall right out. And then you should get
should we use symmetry of or?
yes. You can use symmetry of or and flip them. Did you get it? It worked. Yeah? Good deal.
Yeah.
It did. Okay. Is everybody good? All right. You want to do the next one? The next one assigned was 3.63. .63 is distributivity of implies over equivals. So it's P implies Q equivals R equivals P implies Q equivals P implies R. Woo! That's a big one.
What's more complex?
Well, and also there's a choice as to which equivals you. I mean, you could either get all of this to this one, but I don't think that would be a good idea.
No, I think we should.
What do you think?
The last two in the first one.
Yeah, I think you should get all of these to equivalent this.
Right.
Yeah, I think that's a good idea. Okay, so start with P. So to prove 3.63. start with P implies Q equivales.
We're gonna start with the right side.
Oh, I thought that's what you said.
No, that works.
We could do either way. It might be a little easier to go the other way.
You think so?
I don't know. What do you think? Should we start with the left-hand side or the right-hand side? Shall we start with the left? We could start with the left-hand side. Is that what you're thinking? P implies Q equivales R. Okay, so equals. Now, who's your friend? I think 3.59 is also good here, right? Because if you do,
It's just a way of getting rid of the.
it's a way of getting rid of the implies, and yeah. So I say 3.59. So do 3.59 and see what happens. So those of you who are watching this, you can be doing it if you need to, if you haven't done it already.
Not P or Q. Cool.
So you have not P or parentheses Q equals R. Now that should automatically trigger a pattern that you've seen before, I think. I think that should automatically trigger a pattern. Yeah, by now I hope, does that look familiar? Does that pattern look a little familiar? Let's see. Because you have an or, what you have something or parentheses what? What's the form there? What's the pattern?
Q equals.
Yeah, you have something or parentheses, something equivales something, right?
Right.
So does that
Distribute
Yeah.
or over.
Yeah, immediately you think, does it distribute? Yeah, immediately you think, does it distribute? Because we've got or, right?
Right.
So now let's take a look up here on the ors. And what's one of the things that we see here? See, here we have 3.27. You've got an your P or Q equivales R. So you have something or, and then this equivales. But we know that this distributes.
Right. So choose 3.27.
So use 3.27, yeah. Why not? Okay.
Becomes not P.
Yeah, I mean, you're using it with yeah, not P, yeah, instead of P, right? But still, the form works, right? You do.
And then you use 359 again.
Yeah, and then you move it back again, and then you've got, and then after you move it back,
Oh wait, the knots.
oh, the knots. What about the knots?
No, they're not. Wait, 59 includes.
Oh,
Exactly,
yeah.
exactly. 3.59 includes, yeah, exactly. 3.59 includes the knots.
Okay.
Huh?
What about getting the parentheses? Does that just come with it?
Say it again.
Because like, for example, the answer,
What we're trying to get it to?
yeah, like 63, 2.63. As
We're trying to get it to P implies Q equals P implies R.
With the parentheses, you say.
yeah,
Oh.
I'm just curious.
Are you saying that in 3.63 our author has used some unnecessary parentheses?
Okay, good. Okay.
I think these parentheses are necessary,
Yeah, I would say that.
but I think these parentheses are not, and so he left them there just for emphasis. Yeah, but that's a good observation. That's a very good observation, in fact. Our author did not remove unnecessary parentheses on 3.63. So sometimes he keeps them in there just for emphasis, but Might have been better had he left them out.
3.62 in the 360 place.
Oh, we could have used 3.62.
In 360 twice.
I would have saved this.
And you would have to deal with the 9.
If we had used 3.60, because we already have a P implies Q equals R. So if we had started with the left-hand side and used 3.62, it would have been, oh, but wait a minute, but then how do we get the,
360.
360? Wait, are you, say that again? Yeah, what did you say, how did you say, you use 3.62, and this will be, and that will make it P and Q equals P and R, P and Q equals P and R, but we're trying to get this to P implies Q
360.
equals by 360. So what does 360 say? P
P implies Q equals P. But put the P on the
P,
inside.
yeah. So this P and Q is P implies Q equals P. P, oops. P implies Q equals P. And this P and R is,
No, just drop it down.
Let's keep it there. Equals P or R.
Or R. Just drop it down.
oh, I see. Equals P and R, like this.
Becomes
Yeah,
P,
and
yeah.
then you do it again.
Then do 360 with Q replaced by R.
Yeah.
And then 360 again.
Q replaced by R.
So that would be, what are we doing? Getting, wait.
That stays exactly the same. Look at only the right side.
Becomes P equals R.
Or P implies.
Oh, this is P implies R by 3 points. Oh, yeah. Like that?
Yes, sir.
Well, what do you know? More than one way to skin a cat, as my father-in-law used to say. Yeah, that's nice. But either way, you know, huh? No knots, yeah. Well, I think either way is fine. I think they're about the same length. So yeah. Oh, that's good. Well, that shows alternate ways to do things. Okay, so are we good on that one?
Yeah.
How about shunting, 3.65?
What does that mean?
It means this. The question is, what does shunting mean? Shunting means this. I don't know. What happens when you shunt something? Does that have an English meaning? You know, I don't know that I've used that word in English outside of formal methods. Shunt, doesn't it like mean to move something over some in a certain way? I don't know. Maybe look it up, Google it. See what shunting, maybe here, someone's going to Google it here. I don't know what the English, if there's an English word for it, like modus ponens and modus tollens that we looked up the other day. Okay, so let me see, what do you think about shunting now, you guys? What do you think? P and Q implies R equals P implies Q implies R. Well, it looks like we have two implies on the right side of the equals, which would probably make it more complicated. Is that, do you think? Maybe start with the right-hand side. So P implies Q implies R. Who's your friend?
It seems like 360 would get you there right away, except there's an extra P.
Yeah, that extra P, if you use 360,
Causes some problems.
that causes a problem with that equivals P. Sometimes when you have that extra equivals P or the equivals Q, you can use 3.57 or 3.60, but the advantage of using, the reason 3.59 is so nice is that it doesn't have that extra equivals P or equivals Q. And so you don't have those things, unless you already have the equivals P or the equivals Q, it's usually better just to stick with 3.59. I would suggest sticking with 3.59 and doing it twice. In other words, first do it with this, and then do it with this, and see what you get. Try that.
PQ is QR.
We're just conducting a little workshop here.
Q, 4R.
This is kind of how the study goes, by the way.
Yeah,
If he gives you a problem,
you basically do it. Okay, so you got this one? Okay, and now do P implies that with 3.59. Again.
probably a shortcut.
No, I don't think this is too bad.
Q is P, 4. Wait, not P. Not Q. What am I trying to get to?
Yeah, what are you trying? Oh, that's a good question. What are we trying to get it to? We're trying to get it to P and Q implies R. But I think, now don't you have a bunch of ORs?
2 O's.
Yeah, and so, you know, OR is there P, Q, R, P and Q? But don't you have some knots?
Yeah, with 2
Not, and you have some ORs.
You can write it down if you want. I have not P
I think I can see it.
or not Q or R.
Yeah, not P or not Q or, oh, does that raise a little flag? Because what do you have here? What operation do you have here? This is conjunction, right? You have an and.
I don't.
Oh. Whoa, what do you think? Ha-ha. A little more pattern recognition. What do you think?
There's 2 things it looks like. There's the distributivity of or over or. I don't see what that would be this.
Distributivity of or over or? Yeah, well,
I don't think
yeah, I don't think that helps too much.
and then there's.
But you've got an and here,
Yeah,
huh?
if you want to get an and, you can use the golden rule.
Ooh, golden rule. Ooh, that's going to throw in a lot of equival P's, equival Q's. I'm not sure that's the way to go. Oh, come on. Look. Because what are you trying to get it to? Here, maybe look where you're, here's a hint.
Or De Morgan.
Ah!
Yeah.
Did you hear that? You guys? He suggested De Morgan's. Yeah? Because look, what do you have here? You've got an and, yeah?
Yeah.
But what you have so far is a what?
Ors.
A not, ors, but they have
Not.
knots.
Could we put if we use De Morgan A.
If you use De Morgan, I forget whether it's A or B, you have, what do you have? Not P or not Q?
Right.
So De Morgan
The
A,
thing is the not's inside of the parentheses for the Q.
But because of symmetry, you can change it for symmetry. You can change the parentheses.
Really?
You can change, well, you change the parentheses by associativity.
Or, sorry, yeah.
That's-
Right, associativity. So associativity you can change. Well, you have or, so yeah.
Oh,
You can remove unnecessary parentheses and
Okay. I'll just rub it on the step before that.
just yeah, just remove unnecessary parentheses. But what's the point? What's the key idea here? The key idea here is that you've got De Morgan A, you have a not P or not Q, and isn't that basically what you've got?
Yeah.
So by De Morgan A, that's the same. Now you can change that into what? Wait, not parentheses, what? P and, yeah. And isn't that close to what you want?
Yeah, we're getting closer. Because it's got an and in it.
Because it's got an and in it. Ha ha!
Oh, dang it, I didn't even that step. Just do it. Morgan's.
I don't think you can use 360.
Yeah, I think 360 would lead you astray because you've got that equivals P hanging out there.
I just tried to get rid of it.
And it's hard, yeah.
At that point,
We have alternate, we have every proof that we're coming up with, we're having someone try to get it to a shorter proof, which is good. Nice attempt.
So
Did-
you'd rather us go on to the next page
Yes.
behind it or just the new page?
Next, well, either way.
Alright, so we have not P, or not P or P and Q, or R. And we're trying to get to P and Q implies R.
So aren't we just one step away?
I think we just 350, we can use 359.
Yeah. You know, this,
We can.
yeah, we can use 3.59.
Alright, you're gonna have to explain that to me.
Okay, what do you have so far?
Yeah, then not.
Just tell me, just read what you have so far.
Not, or not parentheses, P and Q, or R.
Okay, so look at 3.59. Take a look at 3.59. And basically what you're going to do is you're going to go from the right-hand side of 59 to the left-hand side. Because you have not something or something.
It'd be PQ replaced by
It's with,
and Q.
you see how to use 3.59 that way?
R.
Because 3.59 says not something or something equivals that first something implies the second something. Yeah, that's now we're getting this.
I was wondering if you grab expressions, if you can just grab one for textual substitution.
Yes, you can. Yes, yeah. That's the heart of textual substitution. Yeah, and like I say, you just do this over and over again. Pretty soon it'll become more and more natural. Of how you, because you have to look at this as saying that anytime anything implies anything else, it's the not of the first anything or the anything else, and those can be anything with textual substitution. So you're looking for the pattern. But see, this really represents, this 3.59 really represents an infinite number of expressions because of textual substitution. Because this P could be anything, as long as it's the same P as there. It's, yeah? Are we good? Okay, what about, what's the next one? 3.70?
Yeah.
Okay, so P and Q implies P or Q equivals P equivals Q.
I think it's the other way around. It's P or Q implies.
Sorry, did I say that wrong? Yeah, P or Q implies P and Q equivals P equivals Q. Okay, now I have a suggestion for you here. That's 3.70. I have a suggestion for you here. What I recommend you do is, this is the complicated side, right?
Right.
And it has an implies. So I think what we want to do is get rid of the implies here and get that to be equivals, P equivals Q, yeah. So so here's how I recommend you start this one. 3.70 3.70, is that what we're doing? 3.70 proof. I recommend we start with this. P or Q implies P and Q. P or Q implies P and Q equals, and who's your old friend? 59, I think. So do that and see what happens. Okay, but now comes something that you might not have remembered. So what do you have? Tell me what you have after you do 3.59.
I have not P or Q
Okay.
or P and Q.
Okay. Does this look... Let's take a look at 3.52. Because here with equivalence we have P equals Q, right?
Right. But both of the parentheses in 352 have ands in them.
Yeah, so we're not quite there, but...
They're not.
Did you hear that?
What did you say, Rochelle? Oh.
This is another De Morgan. Yeah?
Not P and not Q. You're absolutely not.
Okay, I tell you what, we are running out of time a little bit, so why don't you not finish that, and because you said you wanted to take a look at these other ones. So let me get you started on the other ones.
Okay.
3.71. Actually, 3.71, I think you could almost do this one in your head. It's P or P equals true. Well, who's our big friend with implies?
59.
59. I think if you just use 59, because what does 59 say? It says,
Maybe not P or P,
yeah.
which is true.
Well, that's right away. That's not P or P. Does that sound familiar?
It's
That's excluded middle, which is true, and we're trying to get it to true. That's easy. Okay, now, and how about 3.72? That was another one that I think is pretty easy. P implies true. What do you think? Who's your friend?
so not P implies true.
No, not implies.
Or true. Not P or true.
Or true. But then what do you know about or anything or true?
Anything or true.
Yeah. So that's easy. Now how about, so those are just like one-steppers. But now how about 3.70, there's two more that were assigned. 3.76, weakening. How about weakening the consequent? That was one of them.
Right.
Well, who's your old friend? I think my hint on that is to 3.59, and you're good. Now let me just give you one more hint. It's time for us to quit, but let me just give you one more hint, and that was for 3.77. Okay, now I wanted to get to 3.77 because I don't think 3.59 is the way to go on this.
Okay.
So I wanted to make sure that we got to 3.77. So 3.77 says P and P implies Q implies Q. But here's the thing. If you look, can you look back to a previous one and see where else we have had a P and P implies Q?
P and P implies Q.
66.
Yeah.
Yeah. No, Just
3.66, you're right, 3.66, we have a P and P implies Q. So what I would recommend you do here is, well, first of all, there's no equivalence, so we have to start with the whole thing and get it to a previous theorem, right?
right.
You can't start with one side. So what I recommend, start with the whole thing, use 3.66, and then use what? You might just want to jot down this hint. 3.76b, strengthening the antecedent. So there's a little hint for you. All right? And we've got to go. So I'm available for more help with these if you want to, work on them. Hand them in by 5.
Okay.
All right?
Thank you.
All right, good deal.